Good morning, good afternoon, or good evening, wherever or whenever you happen to be viewing this. Currently, there is a lot of talk about the power of data science and what big data can do for business. Some of this talk may be simply buzzwords and jargon used to impress, obfuscate, or to put a new label on old ideas. Then again, some of this talk also pivots around innovative thinking, evolving concepts, and new tools that make a difference in business. We are glad you are interested in seeking some understanding and insights on this field so that you might be able to know what is noise, nonsense, and what might be useful to you in your business about this field. The MAVO Institute is the brainchild of Martin Vonderheiden. I encourage you to take a moment to check out the MAVO Institute website as well as the team's profiles. One of Martin's key hopes is to tap experienced experts to address topics or problems at hand. As such, the team behind this presentation also includes John Murphy, a practicing tenured digital media executive, and myself, Dr. Paul Fielding. This section will give you the ability to answer the question, what is data science? Data science is a huge technical field. This course is for the non-technical person. It is a high-level survey of the underlying foundation of what goes into data science. We'll also cover some of the basic principles of data science and give you an overview of current commonly used tools. This course will not make you into a data scientist. That takes years of study and practice. This course will help you understand the terminology used in the field, know about the basic principles and concepts, and enable you to critically think about types of problems, various tools, evaluate solutions, and be conversant on the topic. Also, it will help you identify what data science cannot do for you, and that is just as important. This section will give you a working definition of what is data science. A UC Berkeley definition states the field of data science is emerging at the intersection of the fields of social science, statistics, information and computer science, and design. Note, it is an emerging field. It has yet to be rigorously defined. Others might have different definitions, and that's okay. What we're going to look at is the intersection of these areas, specifically statistics, information and computer science, design, and social science. Data science at statistics. For our purposes, we're interested in three particular areas of statistics. Basically, descriptive statistics, how do you represent or describe a set of data? Inferential statistics, what can you deduce about the underlying set of data or even its components? And predictive statistics, can one build a model that fits or explains past data while enabling us to predict future results based on actions that can be controlled or observed or manipulated? Basically, you're saying, if I change X, I predict this will happen to Y. This is useful because answers to important problems are often hidden in big data. To find our answers, we must be able to describe the population where our problem exists. Basically, this comes down to, can we see the forest through the trees? We also need to be able to understand what we can infer from that data, what we can know about how the forest is growing, if you will, and sometimes what's happening to the individual trees in that forest that's causing these changes in that forest. Also, we need to be able to determine if we can build a model that reveals what we can do to address the problem or questions at hand. Data science at information and computer science. Information science is the study of the nature, collection, and management of information. Computer science is the science that deals with the theory and methods of processing information and addressing computational problems. This involves data structures, data modeling, and information coding. This is useful because the answers to important problems often require one to find a way to capture relevant data, code the observations, and put those observations into a computer in a way so that the data in the computer is a meaningful representation of the observations that were made. To do this, one needs to create a model or structure into which the data can fit. Then one needs to process the data to get results, alternative possible answers, or basically run simulations on the various questions or proposals that one has. Data science at design, or more fully stated, data science at design patterns. Design patterns is the study that addresses the identification of reoccurring structures that lend themselves to reuse. Or more simply stated, are there patterns in your data? And if you see patterns in your data, what does this tell you about your data? What previous tools have solved similar problems? Or what methods worked in a similar situation? This is useful because the answers to important problems might be found through patterns that arise in your data. By understanding how this current problem is similar to previous problems, one can then apply tools or methods that helped us to solve previous problems, but maybe you need to use those tools or methods in a slightly different way to account for the unique features of this problem. Data science at social science. Social science is the study of human society, relationships, and behaviors. It's basically asking the question of how do I understand the behavior of large groups of people and personal interactions, and what underlies their behavior. This is useful because the answers to important problems might be found by understanding what drives people's decisions and how people interact, and what might influence people's behaviors. So now, if we're asked, what is data science? We can go back to the UC Berkeley definition, which says the field of data science is emerging at the intersection of the fields of social science and statistics, information and computer science and design. Or we can give a more conversant response by saying something like, data science takes the tools and concepts of statistics, leverages the power of computerized methods to help us find patterns and relationships that enable us to address problems or questions involving people's interactions. That is to say, data science happens at the intersection of statistics, information and computer science, design, and social science. In our next section, we'll look at where we might have seen examples of data science used to solve problems, and when might we want to use data science to address a problem our business faces. I look forward to talking with you more then.